Hello everyone. Today we will discuss about the limit of greatest integer function at a given point. So before that let us discuss about what is greatest integer function defined as. So greatest integer function is defined as fx is equal to box x. So this way we represent the greatest integer function for all x belongs to R. Now what is the domain of then this x? So domain of the function, domain of f is your R, the set of real numbers. But the range of f is the set of integers. Now how we get this, that let us discuss first. So greatest integer function of a number means between which two integer that number lies. For example, let us take box of 1.2. So this box value of 1.2 is 1. Now how we do it? We first see this 1.2 lies between which two integers. So it lies between 1 and 2. So from there we say that the box value of 1.2 is 1. Similarly, when we do for a negative one, suppose minus of 1.2. So box value of minus 1.2 is equal to minus 2. Why? Because minus 1.2 lies between minus 2 and minus 1. So its box value is minus 2. So from here we can conclude that for any number, if it is greater than equal to 0 and less than 1, then its box value will be 0. If any number lies between greater than equal to 1 but less than 2, that means including 1 but just less than 2, then its box value will be 1. And for a negative one, let us discuss. Suppose if x lies between minus 1 and 0, that it is greater than equal to minus 1 but less than 0, then its box value will be minus 1. If x is lying between minus 2 and minus 1, that is greater than equal to minus 2 but less than minus 1, then its box value will be minus 2. So we can represent this graphically also. So I'll draw the graph for it. So this is your y-axis and this is your x-axis. I mark it. This is the origin, this is your x-axis, this is the y-axis. 1, 2, 3, this side minus 1, minus 2, minus 3. Positive side of y-axis 1, 2, 3. Negative side of y-axis minus 1, minus 2, minus 3. Now here when x is lying between 0 and 1, when x is lying between 0 and 1, then we draw it like this. Greater than equal to 0 but less than 1, then its box value is 0. When x is lying between 1 greater than equal to 1 but less than 2, then its box value is 1. When it is greater than equal to 2 but less than 3, then its box value is 2. Similarly on the negative side also we can do. So that is when x is lying between -1 and 0, then its box value is -1. When it is lying between -2 and -1, then its box value is -1. So here you can see that at every integral points the function is not continuous. So from here we can discuss the limit then. So first let us discuss the limit at a point A, where A belongs to the set of integers Z. So in that case, when we are doing the left hand limit means when you are approaching x from the left hand side, that is limit x tends to a minus box x, then its box value will be what? Here it is less than a, that means it is lying between a minus 1 and a. So its box value will be a minus 1. And your right hand limit, that is limit x tends to a plus box x, that means it is moving from the right hand side, it is lying between a and a plus 1, then its box value will be a. So we can see that the left hand limit is not equal to the right hand limit. Therefore, limit x tends to a box x does not exist for all integral points. But suppose if a is not an integer, it is any fraction. So if a belongs to is not equal to z, does not belongs to the set of integer, but it is a fraction, in that case let us take an example. Suppose limit x tends to 1.2, box of it. So if you approach 1.2 from the left hand side or from the right hand side, just less than 1.2 also will give you the box value as 1, and if you approach from the right hand side, box value of it will also give you 1. So for any other point in that range, it will give you the same limit. But for integral points, the limit does not exist. Now for all integral points, the limit is not existing, hence the function is not continuous at the integral points. And since it is not continuous, so it is not derivable. So we can conclude that the greatest integer function is not derivable. I hope you like this video. You can share it or put a like, or you can subscribe me. Thank you.